Okay, so today we're going to do our last section of Chapter 10. That's just applying our formulas that we learned, so it's applications of surface area and volume. Again, these can actually be some helpful real-life things that you may encounter in your life, okay, such as how much paint do I need to paint a room in my house or something like that. You are hired at Great America as a coffee barista. There are two types of cups. You have your traditional cylinder cup as well as a special edition cone cup by the racetracks. We have a cylinder here on the left, okay, and the cone here on the right. If the special edition cone cup costs $1 to refill, and you want to give a fair price to refill the Bugs Bunny coffee mug, what should be the price of a coffee mug refill? So when we mean a fair price, we mean whatever I'm paying per ounce should be equal. Okay, so if we think about these two shapes, you have your cylinder and your cone. If we go look at our cheat sheet, okay, and get used to having this because you guys get to use this on your test, we'll see the volume of a cylinder is pi r squared times height, and the volume of a cone is 1/3 pi r squared times height. So you have your cylinder, and then for your cone, you have 1/3 pi r squared times height. Now, let's think about this. We can do this problem without plugging anything in. Okay, pi is the same. They both have the same radius, so the r squared would be the same. And the heights are both 5 inches. So the only thing that's different here is that 1/3, which is saying that this is 1/3 the size of the cylinder. So if we want a fair price here, all I'd want to do is multiply whatever the price is for the cone by 3. So this would make the refill cost $3. Now, you could have plugged in those numbers and saw that the volume of the Bugs Bunny coffee mug was 3 times that of the cone, and you still would have ended up right back at the same conclusion that we just made here. Okay. Let's move on to our next one. You are a shopkeeper, and you would like to order some packaged popcorn to sell. They both cost you $5, but they appear to be different volumes. So we want to figure out which is the better deal. Okay, so we're assuming they're actually filling these popcorns up to the brim. So there would be a difference. We're not going to open it up and find a small bag or a lot of air in one of these. So we need to figure out the volume of both of these. So if we look at the volume of the cylinder over here, we've already used that formula. Pi r squared times the height. So pi times 3 squared times 11. And we want to put this in a decimal form because, if I'm comparing something with a pi and something without a pi, that's not really helping me compare those numbers at all. This comes out to about, because we're going to round it, 311.02, or just 311.0 if you want to leave it like that. And this would be inches cubed because we're dealing with volume. Okay, now we look over here at the hexagonal prism that we have. Okay, so imagine we have a hexagon as the base. Remember, the nice thing with the hexagon is I can break it up into an equilateral triangle, and I have 6 of those. So we're just got to find one of them, which has a base of 4 for that little triangle. So remember, for an equilateral triangle, the area is equal to s squared root 3 over 4. And that is on the bottom of your formula sheet. So it's 4 squared root 3 over 4. Well, 4 squared is 16. Divided by 4 is 4. So we end up with 4 root 3 for that individual triangle. I got 6 of them. So 6 times 4 root 3, 24 root 3. So that is the area of my base, which was a hexagon. And remember, for a prism, your your volume is just base times height. So the area of your base times height. So in this case, 24 root 3 times 10. Again, I don't want to put root 3 in my answer. I want to know what that actually means. And we find that to be about 415.7 inches cubed. So in this case, our better deal would be the hexagonal container that we have on the right. I'm going to skip number 3 and have you guys try it at the end, and I'll just put up the answer so you can stop the video and give that a try. So let's scroll down to the last one, number 4. With number 4, you work for a cosmetic company that makes small cylindrical bars of soap. So this is going to be looked at as a cylinder. Okay. You need to purchase plastic to individually wrap the bars. So we need to find the surface area of a bar of soap. The diameter is 4 inches and the height is 1. So I'm looking at this. The height here is 1. The diameter is 4, which would mean my radius is 2. So we're talking about wrapping it. So we're going to be talking about surface area. And if we need to, you can pull back out your formula sheet. Look at the surface area for a cylinder. We see is 2 pi r squared plus 2 pi rh. So we'll come back to our other side over here. We'll copy that over. 2 pi r squared plus 2 pi rh, which is the height. So again, we're finding 2 bases, and then this is your lateral area going around it. So we got 2 pi, our radius is 2, so 2 squared, plus 2 pi, radius is 2, height is 1. So we get 8 pi and 4 pi. So we see this is 12 pi. Now, as we were talking, we don't want to worry about pi, so this is 12 pi is about 37. Now, they say round your answer to the nearest thousandth, so 37.699 inches. This is inches squared because we are dealing with surface area. Now, that's not the question. The question is, if 75,000 square inches of plastic costs $25, we need to estimate how much plastic it would cost to wrap 5,000 of these. So we know 75,000 square inches cost $25. So we're doing square inches on top, dollars on bottom. That is equal to, okay, we got to figure out how much it's going to cost then to make 500 of these. So I need to take this value down here and times it by, 5,000 of these. So I really need 7.699 times 5,000. I really need to figure out how much does it cost to buy 188,495 square inches. Okay, so we're going to cross multiply here. 75,000x equals 4712375. So 4,712,375. Divide that by 75,000. We're going to see that it's going to cost us about $62.83 to complete that. All right, so I'm going to go up to number 3, walk through it, and you guys can give that a try. The answer is there for you to look at. But what we have here is a gear shown to the left, has a cone-like shape. But you notice the top of the cone is actually cut off. This part has been taken away. And this shape is called a frustrum. This is actually one of my favorite shapes. If I think back to my time in geometry back in high school, we all had to create our own shapes given a certain volume, and I had to do a frustrum, so it was one of my favorite shapes there. So it's a truncated pyramidal cone. We cut off the top. What your goal is to do is to try and find the surface area for that frustrum. And you can use this here to help you get that. So give that a try, and then you can check your answers after.